Lesson 6-2, Properties of Parallelograms. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Look at the red markings. QR is parallel to PS and QP is parallel to RS. Parallelogram QRS is read like that when you use this symbol. So because it's kind of tilted and looks like a parallelogram, that's the symbol for parallelogram. Within our parallelogram, opposite sides are two sides that do not share a vertex. So for example, the reds are opposite and the blues are opposite. Opposite angles are two angles that do not share a side. So angle A and angle C are opposite, and angle B and D are opposite. Consecutive angles are two angles that share a side. So A and D are consecutive, and then B and C are also consecutive. The other thing you'll notice is if I highlight those yellow lines, I know AB and BC are parallel, so then AD would be a transversal. Consecutive interior angles are supplementary. So that's something that could be coming up. Here is a parallelogram YDAL. It says name two pairs of opposite sides. So opposite sides would be DA and YL, and I might as well just list that they are parallel because it is a parallelogram based on the definition. Also based on the definition of parallelogram, DY and AL would be parallel. Pairs of opposite angles would be angle D and angle, that's a typo, angle L, and angle A and angle Y. Four pairs of consecutive angles. So angle D and angle A are consecutive, angle A and angle L are consecutive, angle L and angle Y are consecutive, and angle Y and angle D are consecutive. So there's some vocabulary for you. Facts about parallelograms. Theorem 6-3. In a parallelogram, opposite sides are congruent. So the reds are congruent, the blues are congruent. Also in a parallelogram, consecutive angles are supplementary. So B plus A would be supplementary, C plus D would be supplementary, B and C, and A and B. Why is this true? Well, we were just talking about that. We have these parallel lines, and then if you draw on a transversal, you have consecutive interior angles. So let's try some examples. Part A. Find the values of the variables in parallelogram D, E, F, G. So I color-coded mine. The yellow side is 2x plus 2. Pink is 3x minus 3. Green is 3x plus 1. And orange is 2x plus 6. Well, we're talking about side lengths of a parallelogram, so I think we're going to look at theorem 6-3. And it says that in a parallelogram, opposite sides are congruent. So we can say that the yellow and the pink are congruent, and we could say that green and orange are going to be congruent. And now we just need to solve these equations. So 2x plus 2 equals 3x minus 3. Get our letters together. And then get our numbers together. So we get x is equal to 5. If I were to solve the other equation, I'm going to subtract 2x and I also get the same answer. So I wouldn't necessarily have to do both equations just because there is only an x. Once I solved x, unless I wanted to check my answer, I could just do one of the equations. Part B, find the value of s. So we have these two angles, and I'll call them consecutive, and this is a parallelogram. So our rule is, in a parallelogram, consecutive angles are supplementary. So our equation is going to be 8s plus 5 plus 3s plus 10 equals 180. If I combine like terms, the yellow makes 11s and the pink makes 15. Subtract 15 from both sides, and I get 11s equals 165. Divide by 11, and s is equal to 15. So we found the value of s. Here's some more facts about a parallelogram. Opposite angles are congruent, so A and C, B and D. In a parallelogram, diagonals bisect each other. So this intersection point is the midpoint of both of these diagonals. The next slide says, find the value of each variable in the parallelogram. So in the first parallelogram, we want to remember that the diagonals bisect. In a parallelogram, the diagonals bisect each other. So what that means is that this is a midpoint. So this side is the same as this side, and this length is the same as that length. So our equation is 2h equals h plus 5. So now we need to solve that. We need to get our letters together. So we're going to subtract h from both sides. And then we have 5 by itself. 2 minus 1h is h. And we don't need to do anything with this segment over here because that's an h also. And we already figured that h was 5. Number 2. Again, diagonals bisect, so this piece is the same as that piece. So 2d plus 1 is equal to d plus 3. Get our d's together, so I'm going to subtract a d and subtract a 1. So d is equal to 2. And this is all because of the fact that diagonals bisect in a parallelogram. So here's another review proof. We have two parallelograms, parallelogram QRST and parallelogram TSVU. We are trying to prove that RQ is congruent to VU, so the green is congruent to the pink. So given the two parallelograms. Now that we know we have parallelograms, we have all of these facts about parallelograms. So we're looking at sides. So I think it's important for us to see that opposite sides are equal. So we're looking at theorem 6.3. In a parallelogram, opposite sides are congruent. So that means in our first parallelogram, this bottom one, we know that, or in the top one, VU and ST are congruent, and by that same fact, ST and RQ are congruent, because we know that theorem 6.3 says opposite sides of a parallelogram are congruent. So if you don't remember the theorem number, you could just say opposite sides are congruent. and the same thing for down here. So if pink is congruent to yellow and yellow is congruent to green, then by the transitive property, pink is congruent to green, and that's what we were trying to say up here. Here's another theorem, 6-7. If 3 or more parallel lines form congruent segments on one transversal, then they form congruent segments on every transversal. So because these pink lengths are all the same, then the lengths on the other side also have to be the same. Because these lines are parallel. So let's look at this picture. All of these vertical lines are parallel. So these green pieces are all 2. We know one of the pink pieces is 2.25, but notice these lines are all parallel. So what's going to happen is the lengths from F to G and the lengths from G to H are also going to be 2.5, so I could well mark them. So from E to H, there are 3 sections that are all 2.25, so we're looking at 6.75 units. On the bottom, each of these yellow pieces is 6. We're trying to figure out what this green piece is, and we know that from here to here is 15. Well, I'll call this X, X, and X. They all have to be the same because of the consistencies in the yellow. So my equation is 3x has to add up to 15. So each length would have to be 5. So CD is equal to 5. This concludes my video for today.